Welcome to this video on limits by factoring and rationalization. So previously we looked at solving limits by substitution, but there are more advanced methods to solving limits. And here are two of them. So not every single function that you look at is going to be simple in nature and can use substitution. So let's take a look at this problem. So we take the limit as x approaches 3 of x squared minus 9 over x minus 3. So if you notice that if you plug in 3, then you get 0 over 0. So let's use something called the difference of squares formula. Right? So a squared minus b squared is equal to the quantity of a plus b times the quantity of a minus b, right? So x squared minus 9, x squared minus 3 squared. So we can split that up into x plus 3 times x minus 3, right? And you'll notice that the second term in the numerator and the bottom term in the denominator will cancel out. So that'll just give us the limit as x approaches 3 of x plus 3. And this is where we can use just regular substitution and get our answer, which is 6. So let's take another look at a different problem. This one is what we're going to call rationalization. So sometimes limits will have square roots in them. And it's much easier to simplify these type of rational functions with something we like to call the conjugate. And the conjugate is just the sign opposite of the term that we'd like to cancel out. So in this case, root x minus 2, the sign opposite is root x plus 2. So the conjugate essentially lets us use the difference of squares formula to simplify root x minus 2 times root x plus 2 into root x squared minus 2 squared, right? And the bottom is x minus 4 times the root x plus 2. And if you notice, root x plus 2 over root x plus 2 is just 1. So we're multiplying by 1, so there's no funny business here. And now we can just take the limit as x approaches 4. So the numerator will simplify to x minus 4. And that'll cancel out with the x minus 4 on the bottom. And we have a root x plus 2 left. So the last function that we're left with is the limit as x approaches 4 of 1 over the root x plus 2. So that simplified is 1 over 4. So that's what rationalization is like. Let's take a look at another rationalization problem. So we'll take the limit as x approaches 0 of the root of 4 plus x minus 2 over x. And what we can do here is, again, same idea. We'll multiply by the conjugate. So, but remember, we have to multiply by 1, so it's the same thing on the numerator and the denominator. It's simply difference of squares. So we'll be left with, after this, is whatever the denominators multiplied are, but in the top, we'll be able to simplify very easily, right? So we'll get the left term squared and then minus the right term squared in the numerator, right? So in the numerator, we'll get the square root of the quantity of 4 plus x, and then as we square that term to its right, we'll have minus 2 squared. So I'll just write out this entire process. Yeah, and that will simplify to 4 plus x minus 4, because the square root of 4 plus x squared is 4 plus x, and then 2 squared is 4. So that's just x in the numerator. So we have x in the numerator, and then we have x over the denominators multiplied, which is x times the square root of 4 plus x plus 2 in parentheses, and those x's will cancel. And we'll be left with 1 over 2 plus 2, and that becomes 1 over 4. Thanks for watching this video on limits by rationalization and factoring. Please like and sub if you enjoyed the video, and I've linked here my previous video on limits. Thank you.